We're going to follow on the video here from videos 2 and 3, and I'm just looking at the third in this linked examples. So in this question we're asked what power can be transmitted by a steel propeller shaft 48 millimeters in diameter. The shaft still rotates at a speed of 300 rpm and the shear stress is limited to 90 meganewtons per meter squared. Okay, so in example 2 we looked at the shaft when it was 50 millimeters rotating at 300 rpm, and we saw that we could transmit 69 kilowatts. In example 3 we saw that if we took out this 20 millimeter section, if the outside diameter was still 50 millimeters, we could transmit 67 kilowatts. And in this example we're going to look at the solid shaft again, and this time with 1 millimeter taken from around the circumference, so radius reduced by 1 millimeter. And if the answer turns out to be 61.4 kilowatts, we can see that taking this 1 millimeter off the outside of the diameter of the shaft has a lot more impact than taking 20 millimeters from the center of the shaft. In other words, this shaft here with 20 millimeters out of it can transmit 67 kilowatts, while this one with 1 millimeter taken off the radius can only transmit 61.4 if this turns out to be the answer. Okay, so let's check the answer anyway. So these are the formulas that we use, and I'm just going to populate them with information we have from the question. So we have 48 millimeters for the diameter, the shaft rotates at 300 rpm, and the shear stress is 90 meganewtons. If the diameter is 48 millimeters, then the radius C here is 24 millimeters. Okay, so when I put those values into the calculator, I got J to be equal to 521 by 10 to the power minus 9 meters power 4. Omega works out to be 31.42 radians per second. And if I could look at this equation up here, so T over J, if I cross multiply by J, then the torque will be J times these values. So torque is J times those values. J was 521 by 10 to the power minus 9, and the shear stress was 90 by 10 to the power 6. The radius is 24 millimeters, which is 0.024 meters. That gave me a torque of 1954.3. Okay, so the power is torque times omega. So I have my torque, 1954.3 newton meters. I have my omega, which is 31.42 radians per second. So power is torque times omega. I multiply the torque by the omega and I get 61.404 watts, and that works out to be 61.4 kilowatts. So yeah, that confirms what we thought, that shaving 1 millimeter off the outside of the shaft has a lot more effect than taking 20 millimeters from the center of the shaft.